Okay, so the MPT works with, it has a planner, MPT planner. There are actually, when you get to the MPT, when I'll show you how to do that in APT, it has two panes. It has a planner pane and a plans pane. And the planner pane is where we specify the all the criteria for the MOS observation that we want to do. Specify the size of the search grid and all of the different parameters. And it will work with whatever candidate sets we've defined from the catalog that we select. And there's a primary and a filler candidate set that it allows for. And either one of those can be the catalog itself. What I'm going to do is I predefine the 7 sources as the primaries, and I'm going to use the rest of the catalog as the fillers. And I just want to mention that the ordering of the sources in the catalog is pretty important. And this is why, because as MPT works through a search grid, and in every one of those search grid points, it's going through the catalog in order, source by source, and vetting the shutter that source falls in. And if it's an operable shutter, it checks to see that it meets all the other criteria that you've set in the tool, in the planner. And then it will select that source. And if it selects that source, if it's successful, if it passes all the criteria, what that does is it prevents other sources nearby from being selected in the configuration. So as you're going through the catalog, you're eliminating areas where other sources are viable. Okay, so the order matters. So internally, what MPT is doing is it is creating this heat map, or this from all of the way the search grid was defined. So the heat map has a pixel for every one of the search grid points. So you specify the width and the height of this field and the spacing of the field. So here's one example here. So at each one of the grid points, like I said, it's evaluating each source one at a time to see how many sources it can get into an MSA configuration at that pointing. And then it's tallying up all the sources that I'm talking about just now, the primary sources, because that's what drives the pointing selection. So just for the primary sources, it's marching through, and the primary sources are in the same order as they are in the catalog. So then it selects, the best pointing is selected based on basically the intensity in the heat map, which represents the highest number of primary sources that it can get into an MSA configuration. So it selects the pointing from that, and then it delivers back to you that pointing and the select targets that it got for that pointing and the associated MSA configuration for those targets. So we start defining things differently than you would for any other instrument mode in APT. You don't go to the observation template and start from there. Instead, you go directly to MPT, which is gotten to by, you click on this icon at the very top of the APT window. And then to create a MOS observation, you'll go into MPT and you'll start working with the planner in MPT, and then you will evaluate those plans in the plans pane. And then when you're done, when you've created a whole bunch of plans and you want to select the best one you're happy with, you then click Create Observation from the Plans pane by highlighting that last observation you're happy with. And that sends all of the parameters for the observation are sent back to the observation template in APT, this APT area over here. And then you'll get back into the form editor and fill out whatever remaining details of the observation you need to fill in APT. Okay, I'm just going to go briefly through what the planner looks like and some of the features of the planner, but we're going to see them real time because now I can go to APT and show you. Okay, so we're in the planners where we've got the MSA planning tool highlighted here in blue. See the blue writing. We are in now the planner pane here, so I'm showing all the parameters that are in the planning pane. This is the first half or so of it. This is the APT tree here. So this is the view of the planner and all of its different criteria, okay? So there's a primary candidate set, a filler candidate set. There's this new little checkbox for MOS plus fixed slit mode. And what that does right now is it allows you to plan an individual source in a selected fixed slit at the same time that you're observing your MOS observations. So if you do that, It's limiting in terms of, dithering, of course. It limits you in how much you can dither and still see that source in the fixed slit. And based on your defined aperture position angle, you can only get that source into a slit at one pointing. So, one pointing plus a little margin there to go up and down the slit. So it's very limiting for scheduling in that case. And then here's the planned aperture position angle is defined here. Then you have to select a slit length, a default slit length to use. You can modify the slit length after the fact on sources. I'll just mention that up front. There's a source centering margin, which I'll talk about in the next slide. There's 5 options of that, and that's to help limit the slit losses. And then you select your gratings. In this case, we're going to do both G395H, and we're also going to augment with the prism because we want to see down, we want to detect the continuum for those highly, lens sources at the high redshifts. And this is one way to do. It's always a good thing to do if you can afford the time to do it, is to get the prism observations as well as the G395H observations. And because I'm planning them together in the same plan, they're going to be the same targets that are observed in both gratings, okay, or both dispersers. There's an option there to tune the target spacing. We'll talk about that later on. There are other options now. This is brand new, to do a masking setup, which allows you to curtail the loss of red end spectral cutoffs or blue end spectral cutoffs. And I'll show you a plan on how we use those. The next thing is the search grid. So going on to the next slide here, the search grid is all user defined. It populates the default center for you based on your primary candidate set. And the width and height are defined by the primary candidate set nominally, but they're tunable by the user. And the search step size is something you can tune yourself. What I like to do for a reasonable wait time, runtime, is I like to tune my step size so that I'll set the search grid height and width to what I want, whatever I want, and then I'll tune the search step size to give me basically 10,000 pointings. That's what I like to use for a catalog this size. There are a number of other different options down here. You can use the weights of your catalog. If you use the weights, it orders the catalog by weight and tries them in that order. So it preferentially chooses sources with higher weight. And then there's a feature to enable Monte Carlo shuffling of the catalog. So this only works if you have weight bins, if you have multiple sources that have the same weight in your catalog. And then shuffling them will allow a different order in selection of those sources. So you can run this a number of times. You can make that whatever value you want, however long you want to wait for results. And that optimizes the building of the MSA configuration at every grid point. And then there's this other button to allow the opening of shutters that have multiple sources. So if you're very interested in sources that are very close together on the sky, you can still observe them. Normally, we prevent observation of the same sources in the same shutter because of spectral overlaps that will occur. But some people actually want to do this, and they think that they can disentangle the spectra. And if you think that, you can click that option to get that to happen. And then the last thing I want to mention here is that there's an option to allow sources in the areas affected by those stuck open shutters that I talked about earlier. Source centering constraint. So this is a sketch that I took from this paper by Pierre Ferry. And it's showing how the transmission varies for, and this is at 2.5 microns, for a source at different positions. So it shows the transmission variation through at the different positions in the shutter. The solid rectangle is the open area of the shutter, and then between the solid rectangle and the dashed rectangle, represents the MSA bar that's around every shutter. So normally you would not want to observe sources behind the bar. You can still get some light into the shutter from sources behind the bar, though. I will mention that. So we have the option in the MSA planning tool to allow up to that outer rectangle that you see to allow sources to be selected up to, within that region. So he's labeled positions 0 through 5 here with where the source might be located within the shutter, and comparing the transmission as a function of wavelength now, because the wavelength is different. I'm sorry, the PSF is different for, as you go to longer wavelengths, the PSF grows in size. So the transmission, you have more slit losses, right, in the same aperture. So you're losing some transmission at the longer wavelengths here. That's why it's declining with wavelength. And this shows the relative transmission for those different positions. So relative to the center, which is nominal, everything else falls short of that. Any other position falls short of that. Positions 1 and 3 are still within this oval with the high transmission. 2 and 4 are roughly at the edge of the open area of the shutter. Okay, and those correspond to a setting that I have in MPT called entire open shutter, and they drop in transmission by about 55% or so relative to the central position, just for example. So you can see what actually happens. What we've shown in this collapsed shutter view shows that if you use an unconstrained setting, I'm only representing 3 of the 5 settings that we have in MPT. But if you use that, you get sources that fill that area that you see. Each one is corresponding to the above value of or setting in MPT. So you can see that the sources are constrained more and more as you go from left to right. And this, if you don't have the density of your catalog of sources that you're looking at, you can actually, of course, lose sources on the MSA. You will not observe as many sources if you get tighter and tighter constraint. Okay, so the other options I'll talk about as we do some plans. And then I wanted to say that dithering is very important. And there's different ways to do dithering in MPT. The nods basically are great to use when you have a 3-shutter slitlet, which is like the standard thing to use for point sources, because you've got the target in one of the shutters and the other 2 are for measurement of the local background. So nodding within that slit is a good thing to do. You get it for free because you don't have to reconfigure the MSA. You can also specify a fixed dither in MPT. And when you specify a fixed dither as part of the plan, you can observe the same primary sources through all of the dither points. It doesn't, unfortunately, guarantee all of the fillers to be throughout the plan. So that is one problem we're working on right now. I'll just say that. And then to observe different, you might want to actually observe different sources with each dither point. And to do that, there's a couple of different ways to do that I've written here. You can specify extra MSA configs in the planner. So if your plan takes 2 configurations to complete for 1 target set, you can actually specify 4 and you'll get 2 target sets, or 6 MSA configurations and get 3 target sets. And what I mean by target set is just a set of targets that has been optimized for a given point, a set of pointings if you have a dither. And that whole plan completes, and then those sources are taken out of consideration and it dives further down into the primary candidate set and the filler candidate set and tries to observe more sources with more configurations, of course, so you're paying for them. Or you can create separate plans and merge them. So you can create 2 different plans in the MPT planner and then merge them into one observation to save some overheads. So my general advice is to start with simple plans and then include more complexity with each iteration. That's usually what I'm going to try to show here. And this case has very few primaries. So the first thing I'm going to do is really try to use a tightly constrained shutter centering. And I'm going to try to avoiding doing this tuning here right now. I'm avoiding using the masking. I'm going to set my search grid. So the center that's been put into here is actually computed by MPT from the primary candidate set up here. So it's the center of that area where the 4 sources are. I mean, the 7 sources are. And then the width, actually, I think it's, yeah, actually, that's kind of funny, but I had to, this is cheating a little bit. But in order to get the full width of the catalog, if you specify the catalog as the primaries, you'll see that it tells you how big the width and height is. It computes that for you and the center using the whole catalog. So this is normally how I would specify. This actually is larger than what I was going to use for the first plan. So let's just go back and show you what I'm going to do, which is to select my primaries back again, and then tune this view. Since now we're just using the primary candidate set, it's a much smaller area. I'm going to make it bigger than the MSA size, which is, I'm going to make it 240 because I think it's like 206 by 216 or something like that. So I'm going to make it bigger than that so I can go look for pointings outside of that range. And I've selected 2.5 arc seconds as my step size for this grid because I'm tuning to roughly 10,000 pointings here. So I'm going to use catalog weights. I'm going to shuffle them, and that's all I'm going to use here. And I'm going to generate plan 1. So click generate. It's running now, and it's going to take about 1.5 minutes to complete. And I've already done this for plan 1 that you see in the observation folder of your version in APT as well. So this is exactly the plan that I ran that I'm running now. I'm recreating that plan and calling it plan 1. The way I'm going to make progress through this planning this case is, as I said, find the best pointing for just the primaries and then relax the centering constraint in the end on the final plan. So then I'll be able, when it finishes, I'll be able, it will pop us over to the plans pane where you evaluate plans, and I'll show you how to use some of the features there. Really, the best way to do this if you want to design a real, observation is to make the grid as fine as possible, that as long as you can stand to wait for results. And that actually is more optimal than doing this approach that I'm talking about, because I might be finding a local minimum or a local maximum, I guess. So the plan has finished, and it pops us over to the plans pane. And so now I'm looking at plan. It highlights the plan that was just generated, so which is nice. You can see that I designed it at the aperture position angle of 135. I've got 2 primary sources, 8 secondary sources. This is exactly the same information as the plan I generated earlier. That's an APT for you. It highlights anything highlighted in this box up here gets displayed and highlighted in this box here, which is now the pointings, or it shows, the 3 nods associated with G395H, and then the 3 nod positions for prism. So the 6 exposures in all. This is like the exposure table. And then down below, I can filter the target information contained in all of these pointings can be filtered. And what you see down below is a filtered set of targets. So you can say, targets, I want to see all the targets in every one of those exposures. Or you can say, I want to see just the targets that are in all of the exposures. Or you can say, I just want to see the targets that are missing from at least one exposure. So 3 different ways of looking at things. I almost always keep it in this top one. And here I've clicked all targets. I could just decide to look at primary targets, which are only 2 right now, and I'll explain why. Or filler targets, or all targets, or contaminants, actually. So one thing I can show you is, let's go to contaminants. And actually, some of our highly weighted sources are being picked up as contaminants. And so let me show you why. It's because of the way we designed the plan. Let's go back to all targets here. So let me show you the MSA shutter view. You click show when you want to look at a particular exposure. Okay. And I'm just going to look at the central nod position, which is nod 1. of the grating, which is going to be exactly the same configuration as for the prism. So I'm just going to show one of them. So you can only have 2 windows up like this at a time. So there we are here. The primaries I've already highlighted. So let me show you that feature. So again, you can click. This is all targets. So you can click down on the weight column, and I highlighted just the primary sources in this exposure. So those are what show up. I want to show you that there's a connection between this window here and the MSA shutter window the MSA shutter window that I just popped up. So these are highlighted in pink when I select them over here in the targets area. So now I can zoom by scrolling in this area here. And I zoom in, zoom in, zoom in. Okay, great. Where are all our primaries, right? So those are the ones it planned for, right? So now I'll put in the candidate set for the primaries. And the ones that are in boxes, it couldn't fit in. And the reason is we told it that we wanted a 3-shutter slitlet. And MPT will only allow 1 primary for each slitlet. So, but don't worry about that, because those shutters are all open and those sources are going to be observed whether they're primaries or considered to be contaminants in the plan. The ones that are not going to be observed is when you don't have an open shutter on it. Okay. So in this case, what we normally would do is I kept the 3-shutter slitlet because I liked having the ability to nod and get my dithers for free. So I kept the 3-shutter slitlet. But in this particular case, I cannot even modify the MSA config for the primaries after the fact because I'm up against a shorted row here. So this is the reason I say that this particular pointing is not good for us. Okay, so that's how you examine the plan. Here's the collapse shutter view. This should also be showing these in colored in magenta. I don't know why it's not, but let me click them on again if I can. So it's up to here. Shift to click. Yeah, so there they are and highlighted, the 4 that are observed. So that's showing in the respective shutter of each of the sources where they lie in that shutter. Let's go back to that, click that off. Okay. So that's what all of these, how the plans pane works. Let's put it that way. Okay, so I've generated a plan for plan 1 up here. And let me get back to the slide set because I'm probably forgetting to tell you something. Okay, we've gone through that, defined our plan. Okay, that's me defining the plan there. And then we've looked at the plan results. They're on quadrant. Okay, so I remember the order of it's not labeled, but wherever you locate where the fixed slits are, the one above is quadrant 3, the one below is quadrant 4, and opposite 3 is 1, opposite 4 is 2. So the primaries are in quadrant 2, and I zoomed in on them, and they're in this location here. Okay, so I said that we need a different pointing. Okay, fair enough. Okay, we went through that. I did not describe to you what the different colors mean, so I'm going to do that now. You can see the fixed slits here. I'm zoomed in this screenshot. I'm zoomed in on the 4-quadrant view, and the light orange is again that masked out, real estate basically for the planned sources. So you see that throughout for both the fillers and the primaries. You can see all this masked area. All the white area is available for additional sources if you have them in your catalog. The red areas here, these 3 bands of red here, are from failed open shutters. Somewhere in that masked region is a dark red shutter that's open, and that's the failed open. And then the white areas again are unused areas. The pink area is when there's a conflict. And usually you create one of these when you do manual editing of a config. So it uses the latest operability map when you're creating the plan. The conflicts can only come in even if your if there has been a time span between when you designed with a different operability map, you designed your plan, and then you went back to APT at some later time, and there's a new operability file that it grabbed, and now there's a conflict because it's shown in magenta in your MSA config because maybe there was a new failed open shutter there or something, a new failed open area. And let's see. So I mentioned you scroll to zoom. There are these buttons underneath that actually where you can import and export masks. I'm going to show you that in a little bit. I'm going to do that for you. And then check boxes there are to overlap the catalogs or the candidate sets. And then, of course, there's this all-important send shutters to Aladdin, which I'm not going to show. But if you click that button from the MSA configuration, remember, you're just looking at one exposure's MSA config. You can send shutters to Aladdin to display on top of your image to see where the shutter parameters lie on top of your sources. Okay, so when you go back to the MOS observation template, you have to go between these two things all the time. So you're going back between the MSA planning tool. So usually, I create a plan and then I'll want to look at it in the observation plane, perhaps. So I create observation from the MSA planning tool, and then I can see it as it populates the observation template with the observation. Okay, and then I can see what I've got here. I can see I can look at the visit durations and all of that in this view here. So the planned and assigned angles are listed here. So at some point in time, you'll be assigned an angle and this gets populated. This is if you've submitted this proposal. This is just a sample program, so I don't have any assigned angle. It shows the two different exposure specifications, the two different gratings that I'm using. And at some point, it asks me to select the readout pattern. After I've passed it from a plan to an observation, it'll have a red area here, and you have to select the readout pattern and the groups, the number of groups, and the number of integrations. So those you'll design after your MSA planning tool plan is created. So that's just setting the duration of your observations there. And then down below, because we have just one dither point, but two grading specifications, we have the same config is used. The MSA config is used for both grading specifications. So we have, because I've defined two integrations here, and we have a 3-shutter nod, we're getting 6 integrations on this line and 6 integrations on the other line.